I haven't gotten to where I use Alexa or Google Assistant, but maybe next year that'll be what it'll be like. Scott, remember to start recording. But for now, regular alarm clock will do the trick, I think. All right, and we are recording, so that's good. And so what we want to look at today is 2D arrays, and we'll use KDebug to kind of see what's going on with them a little bit, so get a little bit more familiar with using the KDebugger. And so what we're going to do first is just a straightforward times table example. We're going to use a two-dimensional array as a table, and we're going to fill it with numbers that represent the products in basic times table from, I don't know, third grade arithmetic or whenever you do that. It's been too long for me, so I don't remember what grade that was. But so go ahead and bring up your virtual machine, and we'll just dive into it. Well, actually, no, we won't. We'll actually talk about 2D arrays and stuff first a little bit. Because I've added this page to the notes, and if I added a page, I have to use it, right? So this is just a bit about visualizing arrays, starting with one-dimensional and then moving on. So one-dimensional arrays are very easy to visualize. They're just a list. You can think of a 1D array as being a row or as being a column of cells that you can store things in. So if I define a list of, a variable called myList, that's an array of 7 integers. That's what you would say in C, and you could visualize it this way, or this only has 6 in it, so I guess we would have to say, for that example down there, we would have to say int myList 6, because it only has 6 elements. And if you want to access a specific element, then you say myList and square bracket and the index of the element you want. Very straightforward. So 2D arrays really work. You might almost guess what 2D arrays would look like in C. So if I want a two-dimensional array, first of all, you think of it visually as a table or a grid. All right, a grid of cells, and each cell in that grid you can store a number. All right, here I've started filling in the values of this table with a multiplication table. So 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, and so forth. 2 times 2 is 4, whoops, 2 times 2 is 4, 2 times 3 is 6. So how would you declare a variable like this in C programming? Well, what you can think of, if a row is a one-dimensional array, then a two-dimensional array can be thought of as an array of rows. So here we're basically kind of saying I have an array of 6 rows of 5 columns. That's how you can think about two-dimensional arrays. And so each size, the number of rows and the number of columns, gets its own set of square brackets. And that's the syntax in C. Now, in some languages, they might let you take out that extra thing, and maybe you just separate. You have 2 indexes and you separate them by commas like that or something. C programming languages not do that, but you may find that other programming languages that do 2, 3, 4-dimensional arrays just let you separate the indexes with commas. So particularly, I've highlighted this element here just to give a concrete example that the index of that is row 1, again, because it's 0-based row numbers and 0-based column numbers. So the second row is index 1 and the third column is index 2. So my table, square bracket 1, square bracket 2, is referring to this. Unfortunately, OneNote uses a different color palette for these shaded backgrounds and the background of just plain text, so I couldn't make those colors match. It was very frustrating last class period when I was doing this. But you just have to, they're both green, close enough, right? So at any rate, and in general, if you want a specific cell out of a 2D table, you would put the row index of the row you wanted in square brackets and the column index of the column you wanted. Now there are times when you might want to talk about an entire row of a two-dimensional array. So if you want to talk about an entire row, let me go ahead and zoom out a little bit and let's see. So to reference an entire row, you might say something like my table bracket, just the row index. Okay, there are situations where you want to do that. That comes up with argv. Argv, which is just the list of command line arguments, right? Argv is a lot like a two-dimensional array. And very often you want to do something like this with argv. You say argv and pick out whichever argument you want to look at. Because what are the rows of argv? They're just character arrays, which usually you treat as whole strings. So now there is a little bit of a difference between argv and this 2D table, which is here we have it nice and neat and every row has the same number of columns. Argv actually, each row of argv only has as many columns as it needs to fit the string that it's storing. So that is one subtle difference between argv and the way a true two-dimensional variable work. But most of the things you can do with a 2D array, you can do with argv and vice versa. Now, what if we want to think about a three-dimensional array? Well, first of all, how would you declare a three-dimensional array in C? Not surprisingly, it's just one more square bracket, and how many of that third dimension do you want, right? So that's what it looks like when you want to declare a three-dimensional array. Probably want to have a semicolon at the end of it. And then if you want to access specific elements out of a three-dimensional array, you of course have to have 3 indexes. Question? Or just... Nope, okay. So we have 3 indexes. Now here, your indexes you can think of as being a row and column index, but then, so that's like a 2D table, and then just think of a third index referencing layers or pages. So I didn't actually draw the indexes in here last time, but might as well take a moment to do that. I'm going to start with 0, 0, 0 in my lower left-hand corner, just because it's easier. So your layer numbers could be 0, 1, 2, layer or page, whatever you want to call it, level. And then we can have 0, 1, 2, 3, 4. So those are rows. And along here, columns would be 0, 1, 2, 3. So there's your columns. Or I guess we could number the rows over here as well. 0, 1, 2, 3, 4. So there's row indexes there as well. So that's a way to visualize a three-dimensional array. It's just you're adding, a three-dimensional array is basically an array of two-dimensional arrays. A two-dimensional array is an array of one-dimensional arrays. And you can take this to more dimensions, but then it becomes difficult to visualize. So one thing you can do here for, say, a 4D array is just imagine, okay, a 4D array you can think of as a two-dimensional array of two-dimensional arrays. So here I've kind of started that by, you have the two-dimensional array here, okay, and then inside each cell of that two-dimensional array I have another two-dimensional array. So here I've declared it as a 5x3 of 5x7s. So each of these tiny things in here, that's a 5x7 array. Of course, now you have to actually zoom in. So I've blocked out that element right there. So that would be one integer. and we could access that specific integer with something like, if I named my array variable my 40 array, then index 0, 1, 3, and I left out a square bracket, 3 and 3. So we see, okay, well, row 0 of the big array, so I'm in this row. Then I want column 1 of the big array. Let me zoom out a little bit. So column 1 of the big array means I'm in here somewhere. Let me use the highlighter. So I must be in here somewhere, right? So that's row 1 or row 0, column 1, and then if we zoom in to what I've blacked out here, that's row 3 and column 3 of this array on the inside, and that gets you to one specific element. So that's one way to visualize four-dimensional arrays. You could also, you can imagine a three-dimensional array grid that contains two-dimensional arrays. That could take you to 5 dimensions. One of you said you were ready for 5D arrays, so there you go. You can imagine a three-dimensional grid of rows, columns, and layers or levels, but then in each of those cells you could have another three-dimensional grid inside that cell, so that could get you to 6 dimensions and so forth. So you can kind of take that idea as far as you need to. If you need some kind of arrangement of data that has more than 3 indexes, and you go on to 4 dimensions or higher. We're only going to do 2 dimensions in this class. I don't think we'll. I might pose a challenge problem where you need to do a 3D or a 4D array or something, but for the most part, we're going to look at 2D arrays. And that's much easier to visualize a table now, right? You just have row indexes, column indexes, pick out the cell you want, and you're good to go. So now let's just actually do something. So our goal here is, first of all, to not have our virtual machine have scrambled graphics. Hopefully it'll log in and it won't be scrambled. It's not scrambled, but it hasn't resized the screen properly. There we go, that's better. Or is it better? Okay, I think it's going to let us play. And yeah, so this was our start. Oh, this reminds me. Did anybody look for the solutions to Lab 1 and not find them? Okay, well, I didn't publish them yet. I forgot. But if you do end up looking for solutions that I haven't published yet, and I said I was going to publish them, don't hesitate to email me and remind me. I'll try and remember to do that this evening. But at any rate, let's go on with what we want to do today. And one of the things I want to do is be a little more organized here in my virtual machine, and I do recommend that you be organized as well. I'm going to cd ... up into my documents folder, and I'm going to make use the make directory command, a csc250 classwork folder. And so this is where I can put my future examples that we do in class here. And then let's do cd csc250 classwork. Alright, currently there's nothing in there. I'm going to do gedit, and the program I want to create is called TimesTable. So .c, but I want to encourage you to start picking up a habit of, when you're working on, whether it's homework assignments or other programs for other classes or for your own use for whatever reason, start keeping track of versions and keeping versions of your program as you work on it. So I'm going to call this one v0-v0.c, so timestable-v0.c. And then, so I'm going to kind of get the basics in there, then I'll go to a v1 and so forth. Now the reason I say this is often when you're doing programming, you might get a good start. You got a program that does some of what it needs to do, and then you have to do some of the more complicated, more difficult aspects of it. but then maybe you kind of go down completely the wrong path, and you kind of you don't get the new stuff working, and you've screwed up the previous stuff that was working. How many have already done this? Anyone? Yeah, see what I'm saying? So, keep versions, all right? Do a V0. Get something that works basically. Once you kind of get a nice stopping point, save that V0, copy it to a -v1 file, and work on that. Then, if you screw things up royally, you can always at least go back to an earlier version. How many of you have heard the phrase version control? How many of you have actually done version control of one form or another? Excellent. Git or Subversion? Git?
I do version control for like art and stuff, not for coding.
Oh, yeah, well, even for, it doesn't have to just be for coding. Version control is excellent in any kind of document, artwork, digital art, even just a simple Word document and so forth. Doing some kind of version control so you can go back to previous versions and kind of have a history of what you did. But did you use Git for it, or?
No, every 10 minutes I just save.
Okay, so you just had a good habit of saving previous versions. Okay, which is what I'm showing you here. Just get into the habit of keeping different versions of what you're working on. Now, version control specifically refers to software like it. So has anybody used Git here? You've used Git. Okay, good. Git and GitHub, the website, great tools for maintaining versions of any project you're working with. Doesn't have to be a programming project, but obviously that's one of the most common things. We might actually do some GitHub as part of this class. I might teach that to you as something, and we require you to use it for a homework or something, because I think it's an incredibly good skill and thing to be exposed to if you're going to go on and do any kind of technical computing work, especially in the future. I'm not sure we'll divert time to that, but it's something I'm thinking about. But I would encourage you to, on your own, learn how to use Git and GitHub. If you don't already know how, which it sounds like most of you have not done it before. It's definitely worth investing your time if you're going to go on to do any kind of computing in the future. It's a way to manage your homework assignments in different programming classes, if nothing else. So keep that in mind. But even if you don't do that, just the basic habit of saving, and you can come up with your own way of naming different versions. I think just -v and then a number is fine. Of keeping track of versions of what you're working on. So you can always go back to earlier versions and see, compare, what did you do then? Okay, this was working then and it's not working now. What did I do differently? That sort of thing. So I highly encourage doing that. So for now, I'm going to do times table version 0 here and start that up in gedit, and we'll just dive right into this 2D array stuff. So our goal here is to write a program that creates a 2D array, fills it up with the numerical products of 1 times 1, 1 times 2, and so forth, and then 3 times 3, 3 times 4, 6 times 7, 6 times 8, all that in a nice grid, and then we'll print it out. But first we just want to create the array and fill it, and then we'll use KDebug to actually see what's going on. I don't care about command line arguments right now, so let's just do a void main and no arguments and leave it like that. And so basically what we want to do is create a 2D array. We want to fill it with times table products, and ultimately we want to print the table out neatly with row and column headers. That's our ultimate goal, and we got that far last class, so I think we'll get that far in here as well. So first off, how do you create a 2D array? First of all, what would be a good name for this two-dimensional array?
2D. 2D.
That would be a terrible name.
Okay.
What are we going to use this array for? Times table. What would be a good name for this two-dimensional array? Excellent, excellent. Now it's just integers. We're just doing times table integers. So int is the basic type of the cells of the array. Let's call it times table. Unless you feel really stubborn and you refuse to go along with me on that. And let's make it go up to about 12 by 12. So let's say 12 rows and 12 columns. There's nothing magical about making these two sizes the same. Just depends on what you need. This is a times table. Pretty much need the same number of rows as columns. All right, so that's it. That's how you declare a two-dimensional array, and the compiler, when your program starts up, it'll kind of be created for you. All right, so we've got our two-dimensional array. Now let's actually fill it with products. What we need a row index and a column index, and then we need to figure out what product to put at that cell in the array, and we need to do that for all of the cells. Now very often when you're working with arrays, you have a for loop and you have an index variable. Here I'm just going to have an index variable for row. It should start at 0 there, and and then that's going to go up to, but not including 12, because what is my range of indexes? If the size is 12, they go from 0 to, not a trick question, 11, right. So we want less than 12 there, and row plus plus. But because it's a two-dimensional array, we also have to cycle through the columns. So in here we have an inner loop for col, C-O-L, column equals 0, column less than 12, column plus plus. So we have a loop within a loop. And maybe we need to do something before we start looping through the columns, maybe not, but leaving a space there for now. We come back and think about it later. But in here, okay, all I want to do is put the numerical values, put those products in there. So now I want the products to go from 1 to 12. I want my factors to go from 1 to 12, not 0 to 11. So if I want to store those results in my times table, I'm going to say times table, bracket, row, bracket, column. All right, we use the two indexes, pick out the row and column. What do I want to store there? Well, I want to store row plus 1 times column plus 1. Okay, so that basically, let's think about what this should do. So we come in, we set row to 0. We come in, we set column to 0. We come in and we take 0 plus 1 times 0 plus 1. So that's 1 times 1 is 1. We put a 1 into the 0, 0 cell. Then the inside loop repeats. So column goes up by 1. We're still less than 12. So now we take 0 plus 1 times 1 plus 1. 1 times 2 is 2. So we put a 2 into the 0, 1 cell. And then column goes up by 1, and we do 1 times 2 plus 1. So a 3 goes into the 0, 3 cell. Round and round and round until column gets up to 12, and we kick out of that loop. And then we come back to the row loop. Row goes up by 1. Come back inside. This loop starts all over again. Column starts at 0 again. And we go around and around again. This time we're taking 1 plus 1 times the column number plus 1. So we'll get all the products for 2 times whatever. And then kick around for the row loop again. So you always think about loop within a loop as, okay, the inner loop goes round, 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 finishes, go 1 time around the big loop, come in, then the inner loop goes round and round, round, round again, and so forth. It doesn't look like we need anything before that inner loop starts, so that actually should be all we need. So I'm going to save this, And before even worrying about how do we print it out, let's just take that and run it in KDebug and see what's going on. Question?
You'll have variable names for your loop.
Oh, I didn't declare them? Good catch, good catch. Yeah, we need to declare our int. Oh, somehow my cursor jumped. All right, there we go. So we want int, row, and column. Yeah.
You need to close the second form.
Yep, missing parentheses. Does anybody else see any little syntax errors? Well, the compiler will catch them. So let's see what we've got here. So now I want to do GCC of TimesTable-vo.c. For my -o, I'm just going to use TimesTable, so that my executable will not have the version number after it. You can put the version number there. I mean, you could do this if you wanted to. That's fine. Depends on if you want to keep different versions of the executable around all the time. So GCC looks like it worked. And okay. Now we're ready to run it. Now if we just run it like plain, it doesn't do any output, so we won't see it do anything. It did whatever it did. It filled that array. Hopefully it worked, but we can't see it. But let's run it in KDebug and see it there. But what did I forget in my GCC to make KDebug useful? -G. We want the -G debug option in GCC. So let's put a -G right there. And now let's run it. And now let's do KDebug on TimesTable. And I forgot to put the ampersand at the end, so it's still attached to the terminal here. If you do that, I don't know if I've shown you this or if you know about it already, if you do a Control-Z while something's running in the terminal like this, it pauses it. So I do the Control-Z, and now KDebug is actually paused. I can't do anything. It won't respond to clicks, although I think it might buffer those clicks, so it might start doing something after I unpause it. So right now it's stopped. Notice it gave me this message that the thing that was running is stopped. And then if I do a BG background command that puts the thing that I just stopped into the background, basically it detaches it from the terminal. So the terminal is not waiting for it to finish, and it's running. And sometimes KDebug generates error messages that you just kind of have to ignore. But okay, so now it's over here and we can try to run it. But let's rearrange windows a little bit. Make the KDebug window reasonably large. Bring up the output window, slide that over here so we can see what's going on with that. Although it's not going to produce any output right now, so we don't care that much about the output window. And just to remind you, you might have a different layout here, and if you didn't catch it last time, you can click on the titles of these things, drag them around, so the locals and the watches and so forth, bring them all so they're. I prefer this layout. If you like the layout that you have, that's fine. But I would say drag things around so you just have two sides, especially on a small screen. I think this works better so you can see more source code and the locals, watches, and so forth. And the other thing we want to do here is we want to put a breakpoint right at the beginning, so just put it on the void main line. And you do that by clicking over on the left over here, where I'm making this little red ball up here. That's a breakpoint, which means when I click run up here, it will run and stop and pause at that point, and then we can go step by step through the program. So I'll click run. There we have the green arrow showing we're paused on this line. We're ready to go. And again, remember, you get this warning, GDB failed to set controlling blah blah blah. Just ignore that. It's a quirky bug, and Just it's kind of a sign that your program is running and it's going to put output over in that window. So that's actually a good sign. So now we're ready to step through this thing. Notice that we have our column variable, our row variable, and notice that we also have the times table variable, and it's expandable. Expand it, and you see boom, 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 boom. All of its, basically it's listing all of the rows of times table. You can expand any row, and you can see the columns within that row and the individual cells. So you have like times table row 2 column 5 has a 1 in it. That's just garbage data. Times table row 5 column 8 has looks like 4,195,408. No, I'm sorry, 4,195,408 garbage data. So our times table is currently filled with garbage data. Let's go ahead and step through our program a bit and see what happens. So we step, and we're ready to do the first time through the for loop. Step, and row gets set to 0, and we're ready to start in the first time through the column loop. Step, column is set to 0, and now we're ready to do this line. Take times table 0, 0, we're going to store into that the value of 0 plus 1 times 0 plus 1. So if we expand times table 0, 0, we're looking at this right here, we should see that go to 1. So let's step, and sure enough, there it is, it went to 1. So times table 0, 0 became a 1 because of this instruction here. And notice it went back up to repeat the column loop, the inside loop. Column is still less than 12, if we want to check that. So that loop is going to repeat again. Column should go up by 1. Step, column is now 1. So now we should be looking at this being filled in with 1 times 2. And there we go, 2 went in there. And you can just keep stepping and watch it get filled in step by step by step. Now one thing, unfortunately, KDebug does not give us some nice table view of this two-dimensional array. That would be really cool if it did, but it doesn't. You have to do this expansion, so you're kind of wasting a lot of space when you could see probably all 12 rows and columns in one nice little table here if it would do that for you. But it doesn't. What I would say, just as an aside, is KDebug is just public domain software that there's probably just, well, there's probably one main person that actually writes KDebug. There's maybe a handful of people that occasionally make changes to it. It's open source. I highly encourage any of you that are going on to be programmers while you're students, start to Google about, learn about open source projects. Maybe you end up using KDebug a lot because I've shown it to you here and you like how it works. But you notice something like this, that, oh man, it would be really cool if there was a two-dimensional display of the table of a two-dimensional array here. There's nothing to stop you from joining that project, and once you have the programming skills to do it, adding that feature yourself. Submit it to the GitHub of the project, and if the person who kind of runs it thinks it's a good change, they could put it in, and then the next version of KDebug has it. It's just a general thing kind of for your career, both as a student and as any kind of computer professional. Getting involved in some open source projects like that, especially serious, well, even if they're games and non-serious projects, doesn't matter. Whether it's for fun or something serious, it's a good thing to put on your resume, if nothing else. And it's a good way to start networking, have people that around the world who know you and know your programming skills and so forth, because they've worked with you a little bit on these open source projects. So it's something I highly encourage you to consider looking at doing. But at any rate, now back to KDebug and just stepping through a program and watching what's going on. Another thing you can do, remember, is come over to the watches window to watch more specific things. Like maybe we want to watch times table. And here you can put just about anything here you can put that would be a legitimate expression in C, okay? So I can put times table here, and I can put with the row and column index there to specifically see times table row and column. And I can then add row itself and column itself, so I can just see those change here. And then maybe I even want to see row times column, what that value should be. Oh wait, no, we're really interested in row plus 1 times column, right? So let's put that. So just about any calculation that you could legitimately put into your C program, you can put in this watches list and have it show you that. And of course, we don't really want that one, so you can highlight it and click delete to get rid of it. And now we can kind of watch everything going on. So we can see what row plus 1 times column plus 1 and everything is. So now when we do a step, we should see a 10 go into times table row column. Alright, so we're only on, if we go back to the locals and expand the full thing, we're still, looks like we're still in the middle of just that first row, the 0 row. So let's step over a couple more times. We see the 11 go in, the 12 go in. We can look at the next row, step, step. We see the 2, the 4, the 6, the 8, the 10. Or we can go over to watches here, and now we see that we're on row 1, column 5. And now when we step, we should see that 12 go into times table, row column. There it is. Step. We see the garbage data in times table, row column. It's not garbage data 0 this time. It's 2 million something, looks like 26 million something. But we're about to put a 14 in there. Step. We see the 14 go in, and so forth. And we can keep going. And you can keep clicking step. If you get tired of clicking step and you want to do more at a time, you might try putting a breakpoint. Now, I ran into a quirk with last class. There's some quirks where you put breakpoints and it doesn't quite catch the breakpoint where you think it should be. But let's try where it should be. You should be able to put a breakpoint right here on the row for loop. Then each time it comes back to decide if it's going to do that loop again, it should break there. And then if you hit run, it should just run up to that point and stop. But I'm not sure it's going to work the way I just described. It might miss that breakpoint and just finish out. Yep, it missed the breakpoint and finished running the program. I think the reason it does that is sometimes KDebug, actually it's not KDebug, it's the GDB debugger underneath KDebug, gets confused when you have extra lines of comments in your program, and so it doesn't quite know where you're putting the breakpoints. In this case, if I put a breakpoint on the next line, it's going to act like it's a breakpoint on the first line, which is a little wrong, but free software, something we sometimes have to live with. But we will try editing this file and getting rid of the extra lines and seeing if KDebug figures things out. But at any rate, if I put the breakpoint there, let's run. The program's not running right now, but if I run it, I'm back at void main, run again, and you'll notice we are at row has been set to 0, column is still garbage data. Now if I do another run, it's going to run until it hits that breakpoint again, which should end up cycling through the entire inner loop. So if we go look at the locals and we look at row 0, so here's the first row. Now I'm going to click run. It's going to run all the way till it hits that breakpoint again. And sure enough, it filled in, so it cycled through the inner loop all those times, came back around to that breakpoint. Visually, this is not where it should be, and I've even used KDebug just recently, just setting things up for this class and so forth, where the breakpoints looked like they were in the right spot. So the way it's behaving right now is as if the breakpoint was on this line, not this line. That's not the way it should look. But At any rate, we'll come back and see if we can fix that. But the main thing is to realize you can set breakpoints. So if you want the program to run through a bunch of stuff, you can set breakpoints later and then just click run instead of clicking individual steps. So here we can do run again, and we should see that now that row is filled in. Run again, we see that row filled in. Let's look at row 8 up here. If I hit run, one more, there we got row 8 filled in, and so forth. So we can see KDebug working nicely there, except for the positioning of these breakpoints. But not too bad. Not too bad. So hopefully that gives you a pretty good sense just to visualize it happening and to watch the loops, the loop within a loop and so forth, and how that relates to how you fill values into your array. So what I want to do now, pretty much with the remaining time, is challenge you. Not quite an in-class assignment, but it is a challenge. I want you to try to do this right now, which is print the table out neatly with row and column headers. So basically, well, I'm going to show you what your output needs to look like. So output should look like this. In its simplest form, you probably want it to look something like this. 1, 3, 4, 4. I can't count. 1, 2, 3, 4, 5. And then you want to say 2, 4, 6, 8, 10. Then you want to say 3, 6, 9, 12, except I'm off. My spacing's off. 15, and so on and so forth. So dot, 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 dot. You get the idea. So that's the basics of what I want, but I would like also, so try and get this first. Just try to write what will do this right now. So add to this program and make this version 1 of your program. So save, do a save as v1 and use the initial one here as a starting point. So this is the basic output. All right, basic output should look like this, and then I will copy, paste, and modify that to what the advanced output should look like. The advanced output should look like, now we want row and column headers. So 1, 2, something like this, and then and just to make it look kind of nice, we'll do this, throw in a divider line of dashes, and then we want something like that. It's not an assignment per se, no, but I do want you to do it. So, because your goal is to get at least screenshots for today's class, so you want to try and get it working and get it done. Now, I'm actually going to show you this before the end of the class, but yeah. Yeah, there you go. more room to work. So I'll throw some tips up here. First, you need a loop within a loop, very similar to what we did just to fill the array. So a loop over rows, then a loop over columns within a row. Another thing you need to think about is formatting your integers to a fixed width. So if you don't remember how that works, it looks like %, a number, D, where number is the width. So that way if you have different numbers of digits, you can make sure each one takes up like 5 spaces or 6 spaces at a time, and it just pads out extra blank spaces if it's fewer than that many digits. And you need to think about where and when you need to print a new line. I should say you need to think carefully about that to get it all working. So at least try to get the basic, get a loop set up with some printfs that'll just get this, and then try to get a little bit fancier and get these nice headers and row numbers all lined up. So it looks like, 3 times 4 is 12, right? And I'm going to do a save as and change the file name to v1 so that when I start solving this up here in front of you, it'll be v1 of the program instead of v0. I'm trying something out here, but if you want me to bring the instructions back or tips back up to the screen, just let me know. Do it? No, I don't. Very strange. Very strange. At about 3:30, I'm going to start in on a solution here. Anybody close? It looks like a majority. Anybody finished?
I have a basic one, not finished.
Billion bonus points.
Yeah.
Imaginary ones. I'm sorry, I didn't catch what you said.
I have the basic, but not the advanced.
Okay.
I'm working on it.
So wait, you got the advanced? Or just the basic? The advanced has headers and row numbers.
Yeah.
I can't see it from there.
Advanced.
That looks like a lot more than 12 rows and columns.
I made it modular,
Uh-huh.
so it technically works with any number.
Okay, do you get the input from the user?
No.
Command line argument? You just put it, you have to recompile to change the number?
Yeah.
Oh, come on.
Is it supposed to, like the basic version, is it supposed to keep, as obviously as the numbers get bigger, is it supposed to keep pushing it to the right? Because that's what happens for.
We'll look at that, but the idea, one of these tips here is addressing precisely that.
Oh, yeah.
If you put a number, when you do percent and then whatever, like D or whatever, in the format of a printf, put a number in between there, it controls the width that it uses for what it's going to print, and it'll just pad it out with extra spaces so that you always get the same width every time.
So then it should look square.
Right, then you can have all the columns lined up and like have the, even have them right, they're by default, the numbers are right justified within that gap, so they'll line up neatly with the digits all aligned and everything.
Yeah.
That's the one spot, actually.
Google printf format, and you'll find 1,000 web pages with all the information you'd ever want about how to do that stuff. There's a lot of other tricks in there. Alright, it's 3:30, so I'm going to start in on my solution to this.
Yeah, that works pretty well, that spacing thing.
Mm-hmm.
Barely did anything, it looks 10 times.
Yeah. Did you not do that in 150, or did you just forget?
No.
Really?
Yeah,
Oh, yeah.
He talked a little bit about like formatting
Mhm.
and stuff, like how to cut off floats.
Right.
Printf, he talked about that. He didn't go into very much.
Oh, so to control the number of digits after the decimal point?
Yep.
Yeah. Yeah, when you start wanting to get like nice tables printed out and so forth, then you have to know how to do the spacing. So, as I said, we just basically want a loop within a loop. So we can just reuse our row and column variables for this. Start them over.
It's not pretty, but it works.
And then basically we just want to, where here we were setting the values, we just want to print the values. And I'm going to deliberately do stuff and then fix it in increments here. So right now I'm just going to print that number out, the times table number at that row and column. And mainly I'm kind of doing this to illustrate another habit that I strongly recommend getting into, which is, getting basic things working and then make small changes, rebuild, rerun to test again. Now, some of the things I'm leaving out you may already find to be pretty obvious. That's fine. I'm not saying you have to do every little increment that I'm showing you here, but part of this is also so you kind of see how, again, kind of reinforce how printfs work and so forth. So right now I just loop over rows, and within each row I loop over columns, and then I just print a number, and the number I print is times table, that row and that column. And let's see, I don't want to have that missing parentheses, so let's get that in there. And if I didn't make any silly mistakes, which I suppose you could say I have done on purpose, but now I'm on my V1, so I want to change my source code line there that I'm compiling. And this time I just want to test it right here on the command line. Notice that even when you do the -G option, you can just still run the program normally. And still no output. Why did I not get any output? You know what, I'll bet I did. I had both my versions open and I edited my V0. So V1 is V0 and V0 is V1. Let me show you a new Unix command that you might not know about. I'm going to close this gedit because I'm going to change those files around. So let me do an ls. We have timestable V0 and timestable V1. I'm going to move timestable-v0.c to times. Actually, I'm just going to move it to a file called temp. All right. Move is actually rename, but if you put paths in there, it can move it to another folder as well. So mv for move, which is also rename. So now I have a file temp instead of v0.c. I still have the twiddle, the file name twiddle. If you didn't catch it before, if you set auto backup in your gedit program, it'll create these the same file name with a tilde at the end. So now I'm going to move timestable-v1.c to timestable-v0.c, and then I'm going to move temp to, that's a little swap thing, just like when you do the swap of the variables in sorting, you had to have that temporary variable. Well, same thing here. So I'm going to move temp to timestable-v1.c because I edited the wrong one, and now I'm going to gedit my v1 file. That's one thing, if you do these different version file numbers, you need to make sure that you're editing that you actually wanted to edit. Probably not a good idea to have them both open in the editor at the same time. Alright, so here's my v1. Let's save that just to make sure it's saved, but I didn't make any changes, so it should be fine. Now when I do my GCC and I do my source code of v1.c, it should build the right thing. Now when I test it, there we go. So, okay, I'm printing out a bunch of numbers, but they're all run together. Probably need to at least get like a /n in there, but if I just do this, that's probably not where I want it. Because this is going to put a new line after every number. So now if I run it that way, so rebuild, rerun, now I just get a long column of all the numbers. Also not what I want. So as I said in the tips, think carefully about where and when you want to print a new line. So if I've printed all the columns for one row, that's probably when I want a new line. So let's just put a printf /n after the column loop. So it's not inside the column loop, it's after the column loop, but it's still inside the row loop. So we'll get the new line at the end there. So let's do that. And again, apologize if for several of you this was pretty easy enough to work through, but I want to make sure everybody kind of sees the process. I probably want to have spaces after each number or to control the width. First I'll just do spaces, put a couple spaces after each number, and we should be starting to get to something that looks like a table. There we go. So now we come to your question where you were asking about, well, everything gets shifted over when we have extra digits, right? So that's where the formatting in the printf comes in. So I just put a number between the % and the D here. Let's go with 5. That's going to say always use 5 spaces to print these numbers, and it'll just put extra spaces in if the number is fewer than 5 digits. If the number is bigger than 5 digits, then it'll overflow what we reserved for it and throw off the alignment. But as long as the numbers stay 5 digits or smaller, we should be good to go. So let's save that and rebuild and rerun. And now we have the basic times table that I asked for. So what's left, we want to get the headers and row numbers. The row numbers are pretty easy. Let's do those first. So to get row numbers, basically think, okay, before I do print all the results for a column, I want to print the row number. So that's pretty easy. Just do that before the column loop. So printf and maybe a couple spaces and then the number, actually, well, let's use the formatting, so %5D, and then maybe another space and a vertical bar, because if we remember from my comments that are now saved only in the version 0 file, but I'm going to live dangerously and have them both open at the same time. So this is kind of what we want the row numbers to look like. So the number itself and then a vertical bar. So let's come back over here. Whoops. Where's my gedit with these? Ah. Oh wait, I want times table, not lab 1 word count. There we go. So, but I don't want the version 0. I want that. So that should look all right, I think. And so what do we want there? We want the row number itself. Well, that's the row index plus 1 is the number that we used as the multiplier. So I want to say row plus 1 there. And so that should take care of the row numbers pretty well. So there we go, row numbers and then a nice vertical line separating them from the table. Okay, so far so good. Now column headers. Well, depending on how you think of it, a column header needs to happen for each column. So your instincts might take you to do something like this. Printf, and then format it, right? And then you want the column number the column index plus 1 to get the number there. Well, is that going to work? Probably not, or I wouldn't ask, right? But let's try this and see what that does. Looks like we have a lot of extra numbers there. If I zoom out my terminal so the text is smaller, I can get rid of the wraparound and we can see what's going on here. So there's what it printed out, but basically what I'm getting is I'm getting the column header with every number in the table, right? Well, that's because of where I put it. I'm printing the column header, then I'm printing the number, and that's happening every time in this inner loop. Remember, that inner loop's going to go round and round and round and round. Then the outer loop comes round for the next row, and the inner loop's going round and round and round and round. So yeah, clearly I don't want to print the column header there. Let's take that out. What I really want to do is just do that all before I do this. But if I try and do it here, well, that wouldn't even mean anything, right? I mean, column isn't really even set before I start going through the column loop, so that doesn't make any sense. So we don't want to do it there. What we want to do is before we even do the loop that's doing all this other stuff, this is where I want to do the column. So I actually have to have a separate for loop that only goes through columns to set up those headers. That's starting to get us closer. So let's save that and see what we've got. We're going to need a few more pieces, then it's just a matter of kind of lining things up. So let's rebuild, rerun, and now things are a little better. It looks like I've got one long line run together here, so I probably need a new line somewhere that I forgot. But we're not printing the column header with every number in the table now, so that's good. So I can actually zoom back in a little bit here. Make it more visible. And now let's come back over, and I think we can wrap this up in a couple minutes. So after printing all the column headers, I probably want to print a new line, so then the rows start on a new line. So that's what I left out there. So let's just printf a new line right there. So far so good. And well, let's just build and save and see how that looks. Alright, so now here's my column head. Column 1 should be above this column, right? And column 2 should be above that column. So I have some alignment issues. So basically I want to get some extra spaces or something to push all this over before I print all those. So how can I do that? Well, before this loop, I can just put a printf before that. Printf, space, space. And to make it look like what I had, I think I want an asterisk, a couple more spaces, and a vertical bar. That's probably what I want there. And I also want that row of dashes, right? So printf, some dashes, and then I had a plus sign in there, and then a bunch more dashes. Good enough for now. We can see what we get with this and fix it. So, once again, I left out a new line. This plus sign isn't quite lining up, but we're close. Looks like I need to move that over, move a couple things around, and we're pretty good. So, let's see, I think I needed to move the plus sign back one, and maybe move that vertical bar over one. I think I like it better that way. And I need a new line at the end of the dashes, so let's do that. Save. Now let's see how that looks. So rebuild, rerun, and whoops, I still need to take out one dash there. And my spacing on the column headers is not the same as my spacing down here, so I need to fix that. I thought I used 5D, %5D on both of them, but maybe not. Oh, I have %5D in here, but I have 2 extra spaces. I don't think I really wanted those extra spaces, so let's take them out. And I need one less dash there, and I think that's everything, and it's all lined up. And there we go. Now we have the table pushed out. So I guess I'd maybe leave as a challenge. Try, and one person among you has already done this. Try and get input from the user or a command line argument to control how big of a table you actually print. Instead of 12 by 12, do 10 by 10 or 20 by 20 or whatever. I mean, eventually you're going to kind of run out of space, but you can actually zoom these things way out. So, whoops. How small can you get it? So you can zoom way out, so you could actually get a really big times table in here. You could probably go, looks like I could go 12, 24, 36, 48. You could do, say, 64 by 64, and 64 is a power of 2, which computer scientists love powers of 2, so, but make it a command line argument, the size of the table. Who knows, maybe that'll be one of the programming assignments in an actual out-of-class lab. And since you already know most of it, you just have to get the command line argument in there. So, something to try. Do some other experiments. Take this and do some experiments. Make sure you understand what's going on. And I do have a recording of this class which will be up, so if you were not following everything and you want to pause and make sure you understand all the steps I did there, you can go back and watch the last 15 minutes and hopefully that'll help. So at any rate, we're done. Oops, 2 overs. Yeah. I'm sorry? You missed the very last bit? Let me just bring it back up there for you. Sometimes just little bits will throw you off. What's your output looking like?
Just put in that figure there.
Okay, well you're missing a new line after the dashes, and then I think it's just a matter of deleting or adding some spaces here and there.
Oh. So That's
Five,
something else.
five.
No, that's okay. It's hard to keep up when I'm just typing and making changes, but that's why there's a video so you can actually go back and pause if you need to later.
I was trying to keep up, and somehow I turned the whole selection thing to black. I don't know how I did that. Oh, there you go. Is there any real reason why? I mean, besides us going against our what we would think is right, why would that putting the columns outside the regular for loops?
Well, it's just like the header is not like the table is all laid out there, okay? So row, go row by row, column by column, but the header is something that just happens once. So that's why it's separate. Does that make sense? So let's see if we look at what it actually looks like when it comes out. And if I zoom back in, whoops, let's see. Let's look at the final version. So, you know, the header is kind of a special case because you only want to print the header once. You only want this row of dashes once. So if this was inside the loops that do all this, then you'd get you'd get those dashes all over and over and over again, and it would be throwing everything off. Or you'd get these header numbers over and over and over again. So that's when we had this mess up here when we tried to put the headers on the inside of the loop, right? We get, so like this is the header 1, header 1, header 1, header 1. So all of these ones we really just want to be this one right here. And then if we go back here, all of those 2s, we end up with
So it's just
we just want the one header for the 2 there, right?
it's more efficient.
Well, it's not a matter of efficiency; it's a matter of what we want it to look like. We're printing a times table, so you know we want to say something like 4 times 6 is 24, right? We're building that table, and so it's just a matter of how do we write the program in a way that actually prints the way we want it to look, right? So to get the headers, you need to just do all that first. Then you can have the loop over and over. Now to get these, those are within like each row. You need the row number for that row, but then you need the loop of the columns that prints all the values for each column within that row. So that's why we have over here, you know, inside. So we have a loop that is for row, goes from 0 to 11. We print off that row number, right, which is row plus the row index plus 1. We print that. Then we print all the column values from the table for that row. Then we print the new line to start the next line, and then we come back and row can go up by 1, and then we do it all over again.
So let's say you put like the bottom dash, like Excel style. Would it be very similar to what we did with the rows?
So yeah, well, if you wanted to like a dashes on the bottom as well, and maybe you'd want like, maybe this isn't a times table, maybe you want to do sums and have the sum of each column. So you'd want a dash, 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 dash. Well, then you'd have the loops that print the table, but then you'd have like a printf by itself after all those loops to print that row of dashes at the bottom, kind of a thing. So you just have to think about when you actually want different pieces to print out and just make sure they're in the right place. So some stuff goes before the loop, some stuff after the loop, some stuff in the inner loop, some stuff needs to be in the inner loop, some stuff needs to be in the outer loop but before the inner loop, some stuff needs to be in the outer loop but after the inner loop. Just kind of depends. You have to figure out, you know, where the different pieces of what you're printing out need to go in relation to all these loops.
And how long is that classroom thing going to be?
Classroom
This week?
thing.
Like, somebody have screenshots for this week?
Oh,
Is that already closed?
no, that's not closed yet. I think I set it as a deadline tomorrow midnight, Friday midnight, but it's not really a big deal if the turning the screenshots in a little late. I don't care about. That's when my
Just to show that we were in
yeah
the
my deadline my hard deadlines are really on the labs because I really want you to catch up on all of this stuff. So if you have to go back and watch videos and catch up and so forth, I really want you to do that. So
I'm
Yeah.
just asked a few questions because I haven't really done anything with presentation in the 150 class, so I was just wondering.
yeah, just send me questions in email anytime. I usually answer pretty quickly. Okay,
Thank you.
sure thing.